March 1978, just before dawn, deep inside a reinforced concrete bunker on the outskirts of Kaliningrad, a senior Soviet radar and navigation engineer stands over a dimly lit console, the air thick with cigarette smoke and the low hum of aging electronics. The walls are lined with analog instruments, oscilloscopes flickering in tired green lines, paper maps marked by hand, and red pins carefully placed to represent a world the Soviet Union believes it fully understands. Outside, the Baltic sky is cold and heavy, the kind of morning that feels permanent, unchanging. Inside, the engineer adjusts his glasses, calm, almost bored. This is familiar territory. This is a system he helped build. War to him is math, radio waves, timing and discipline, and he trusts all of it completely. At this moment, Soviet military doctrine feels solid, proven, and rational. Navigation depends on ground-based beacons, long-wave radio signals, inertial systems that drift slowly but predictably. Missiles, aircraft, and fleets move according to calculations made by human minds and verified by human instruments. Nothing in this room suggests vulnerability. Nothing here hints at surprise. The engineer has been trained to believe that every signal can be jammed, every transmission intercepted, every advantage eventually neutralized. The Americans, in his mind, are powerful but predictable. Their technology is loud, expensive, and visible. If they move, the Soviets will see it. If they strike, the Soviets will measure it. What he does not know, what no one in this bunker knows, is that far above the cloud cover, beyond the reach of radar and doctrine alike, something entirely new is quietly taking shape. Not an aircraft, not a missile, not a weapon in the traditional sense. A system without a front line, without a sound, without a warning. A system that does not care about borders, weather, or human error. In a matter of years, it will make rooms like this one obsolete, calculations meaningless, and certainty dangerous. On this cold morning in 1978, the Soviet engineer believes he is watching the future of war unfold. In reality, he is standing at the edge of its end. Before the rupture, war followed rules that had been refined for decades, and to Soviet engineers and planners, those rules felt as solid as physics itself. Conflict was a matter of mass and measurement. Armies advanced along mapped corridors. Aircraft navigated by radio beacons fixed to the ground. Missiles followed inertial paths calculated before launch, their errors known, their limitations accepted. Every movement could be traced back to a signal, a frequency, a coordinate that could be disrupted or destroyed. In this world, control came from infrastructure, and infrastructure could always be targeted. War, in its essence, was a system of inputs and outputs, predictable, analyzable, and ultimately manageable. Soviet doctrine was built on this certainty. Victory came from overwhelming force, layered defenses, and precise timing. Radar stations formed an unbroken chain across borders. Early warning systems watched the skies. Navigation depended on terrestrial transmitters and human correction. Even uncertainty had boundaries. Engineers knew how much drift an aircraft's inertial system would accumulate. Commanders knew how long a missile would take to reach its target. Planners could simulate entire campaigns on paper, confident that reality would not stray far from the model. The battlefield, though deadly, obeyed logic, and logic could be mastered. This predictability created comfort. It allowed confidence to harden into belief. If an enemy aircraft appeared, it would announce itself through radar reflections. If a strike was launched, its trajectory could be calculated. If a fleet maneuvered, its position could be estimated by signals bouncing off the Earth. Nothing truly arrived without warning. Nothing truly vanished without explanation. Even deception had limits, because deception still relied on the same physical constraints. The game was brutal but fair, a contest of strength, speed, and endurance within a known framework. For Soviet engineers, this was not arrogance, it was experience. They had built systems to fight this kind of war. They had tested them, refined them, trusted them. Every new American development was analyzed through this same lens. Faster aircraft meant stronger radars. Longer-range missiles meant deeper defenses. More complex electronics meant more opportunities for interference. The balance was harsh but stable, and stability bred confidence. As long as war remained tied to the ground, to signals that traveled in straight lines, to calculations made before the first shot was fired, the Soviet Union believed it could see the battlefield clearly. and in seeing it, control it. The first anomaly does not arrive as an explosion or an alarm. It arrives quietly, almost politely, hidden inside routine reports and minor discrepancies that seem too small to matter. During exercises and intelligence reviews, Soviet analysts begin to notice something unsettling. American aircraft are reaching their targets with an accuracy that exceeds known limitations. Naval groups appear to maneuver with unusual confidence, even in poor weather or radio-silent conditions. Missiles land closer to their intended coordinates than inertial systems alone should allow. Nothing is openly broken. Every instrument is working, and yet the numbers are wrong. Engineers check the data again. They recalibrate assumptions, adjust error margins, blame favorable conditions or exceptional crews. Perhaps the Americans have improved training. Perhaps they have refined their inertial platforms. These explanations are comfortable, familiar, and technically plausible. But as more reports accumulate, the pattern becomes harder to ignore. The improvements are too consistent. The accuracy holds at night, in storms, across continents and oceans. It does not degrade with distance. It does not drift over time. According to everything Soviet doctrine teaches, this should not be possible. Still, there is no panic, only unease. In briefing rooms and laboratories, conversations lower in volume, charts are redrawn, equations are pushed further, stretched to their limits to make reality fit the model. No one is ready to admit that the model itself may be wrong. The systems, after all, show no obvious interference. There are no new radio signals to jam, no transmitters to destroy, no clear source of guidance to target. The Americans seem to be navigating without touching the battlefield at all. For the first time, Soviet engineers face a problem that cannot be located on a map. The anomaly has no fixed position, no physical footprint. It exists everywhere and nowhere at once, and that is what makes it unsettling. War is still functioning, commands are still issued, weapons are still launched, but something invisible is quietly removing friction from the American side. The old rules have not yet collapsed, but a crack has formed. And through that crack, a new kind of warfare is beginning to show itself, one that does not announce its presence until it is already too late to stop. The shock does not come with sirens or a declaration. It comes in the form of operations that simply fail to unfold as expected. Soviet observers watch American forces move with an efficiency that feels unnatural, as if uncertainty itself has been removed from their side of the battlefield. Strike packages arrive precisely when planned. Naval units coordinate across vast distances without detectable guidance signals. Targets are engaged and destroyed with a level of synchronization that should require constant communication, yet the airwaves remain eerily quiet. To Soviet commanders, it feels less like an enemy advance and more like the sudden loss of control over the environment itself. In exercises and real-world confrontations alike, something unprecedented begins to happen. Soviet countermeasures are activated on time, executed by the book, and achieve nothing. Jamming produces no confusion. Deception yields no delay. Units that should have intersected American forces miss them entirely, as if the battlefield has shifted without notice. Decisions made at headquarters arrive too late or prove irrelevant upon arrival. Timelines collapse. Carefully planned responses dissolve before they can take shape. The machinery of command still turns, but it is no longer connected to outcomes. From inside Soviet systems, the experience is deeply unsettling. There is no single point of failure to repair. No radar screen goes dark, no communications hub explodes, and yet coordination erodes. It is as if an invisible hand has turned off friction for one side while increasing it for the other. The Americans do not appear faster because their machines move quicker. They appear faster because they already know where everything will be. Where Soviet forces react, American forces arrive. To those watching from bunkers and command posts, this does not feel like combat. It feels like an eclipse. Information vanishes not through destruction, but through irrelevance. The old levers of war, timing, positioning, interception, no longer respond when pulled. In the silence between reports, a terrifying realization begins to form. The battlefield has not been overwhelmed by firepower. It has been quietly bypassed. At first, the Soviet response is not fear, but denial. The explanations come quickly, drawn from habits formed over decades. A calculation must have been wrong. A crew must have made an error. A technician somewhere failed to calibrate a system correctly. These are comforting conclusions because they preserve the old logic of war. The idea that outcomes are still controlled by human precision and mechanical reliability. Reports are sent back down the chain with red annotations and cautious language. Anomalies are labeled as exceptions, not evidence. Engineers return to their instruments and begin tearing through data with disciplined intensity. They recheck timing sequences, inspect inertial platforms, analyze signal logs frame by frame. Every deviation is hunted, every inconsistency isolated. Yet no matter how deep they dig, the core problem remains untouched. The systems are functioning within their expected parameters. Drift is present, but not enough to explain the results. Communications show no signs of compromise. No new frequencies appear. No foreign transmitters are detected. According to the rules they know, nothing extraordinary has happened, and yet everything has changed. As confusion grows, explanations become more strained. Perhaps the Americans are taking unacceptable risks. Perhaps their accuracy is a statistical illusion. Perhaps several independent failures have coincidentally aligned. These theories begin to stack on top of one another, fragile and contradictory. Each new incident requires another exception, another footnote, another quiet adjustment to what should be possible. The logic that once simplified war now complicates it, forcing engineers to bend reality until it nearly breaks. In closed meetings, voices lower further. Confidence gives way to unease. The most troubling realization is not that the Americans have improved a system, but that they may be operating outside the system entirely. The old framework no longer explains cause and effect. The more Soviet analysts apply familiar reasoning, the more inadequate it becomes. What they are witnessing cannot be fixed with better maintenance or stricter discipline. It cannot be jammed, intercepted, or reverse-engineered through traditional means. Slowly, uncomfortably, a truth begins to emerge. The problem is not a failure within their machines. It is a failure of their assumptions. The investigation that follows is methodical, thorough, and deeply unsettling. Soviet teams collect everything they can: telemetry fragments, mission timelines, after-action reports, eyewitness accounts from pilots and naval officers who swear they followed orders precisely and still arrive too late. There are no wrecks that reveal secret components, no captured devices that can be disassembled on a workbench. Instead, the evidence is abstract: timestamps that do not align, coordinates that appear too precise, maneuvers executed with confidence that should not exist under radio silence. The battlefield offers no tangible clues, only absence. Testimonies are especially troubling. Crews describe a strange sense of inevitability, as if American forces anticipated movements before they occurred. Pilots report enemy aircraft appearing exactly where interception should have been least likely. Naval commanders speak of U.S. vessels arriving at optimal positions without detectable guidance, unaffected by weather or terrain. These accounts are cross-checked, stripped of emotion, reduced to data points, and yet they remain consistent. Different units, different theaters, same pattern: precision without visibility, coordination without communication. As analysts assemble the data, an uncomfortable picture takes shape. This was not an advanced missile, not a superior radar, not a faster aircraft. Every traditional category fails to explain the results. There is no single weapon to blame, no platform that can be targeted in retaliation. What defeated Soviet expectations was not firepower, but certainty. The Americans did not overpower defenses. They moved as if those defenses were irrelevant. For engineers trained to fight machines with machines, this realization is humbling. Their education prepared them to counter strength with strength, speed with speed, signal with signal. It did not prepare them to face a system that exists above the battlefield rather than on it. The conclusion, once unthinkable, becomes unavoidable. They were not outgunned. They were outmatched by something fundamentally different, a layer of warfare they had never been trained to see. The revelation does not arrive dramatically. It emerges slowly through classified briefings, intelligence leaks, and fragments of Western technical publications that, when assembled, reveal a picture both simple and terrifying. The name appears almost casually at first, buried in reports and satellite catalogs. NAVSTAR, the American Global Positioning System. Not a weapon, not a platform, a constellation, a network of satellites orbiting the Earth, silently broadcasting time and position to anyone equipped to listen. To Soviet engineers, the concept is deceptively straightforward. Precise clocks in space, signals traveling at the speed of light, receivers calculating position by measuring time itself. On paper, it sounds almost elegant, even harmless. But as the implications unfold, the room grows quiet. This is not guidance in the traditional sense. It does not depend on ground stations that can be destroyed. It does not rely on continuous communication that can be jammed. It does not degrade with distance, weather, or terrain. It exists above borders, beyond interception, and outside the battlefield entirely. The realization hits with crushing clarity. NAVSTAR is not helping American weapons aim better. It is removing uncertainty from every level of warfare. Aircraft no longer guess where they are. Ships no longer estimate their position. Missiles no longer drift blindly after launch. Every unit, every platform, every operation shares the same invisible reference frame, synchronized by atomic clocks in orbit. Time and space themselves have been standardized and weaponized. In that moment, the game officially changes. War is no longer decided solely by who has more firepower or thicker armor. It is decided by who knows where everything is at all times with unshakable confidence. NAVSTAR does not replace existing weapons, it transforms them. Old systems become deadlier, new doctrines become possible. Coordination reaches a level Soviet planners never designed their defenses to counter. What once required massive infrastructure on the ground now happens silently from space. For the first time, Soviet engineers understand the true nature of what they are facing. This is not an American advantage that can be copied quickly or neutralized with a countermeasure. It is a systemic shift, a reorganization of warfare itself. The battlefield has been lifted off the Earth and placed into orbit, and from there, it will never return to the way it was before. As the implications of NAVSTAR settle in, another, even more sobering question follows. Why not build the same thing? At first glance, the answer seems obvious. The Soviet Union has rockets, it has satellites, it has brilliant mathematicians and engineers. In theory, nothing about the system appears magical. But as planners begin to trace what NAVSTAR actually requires, the scale of the problem becomes impossible to ignore. This is not a single breakthrough. It is an ecosystem, and the Soviet system is not built to sustain it. Economically, the burden alone is staggering. NAVSTAR demands a continuous constellation of satellites, not one or two, but many, constantly replaced, maintained, and upgraded. It requires launches on a predictable schedule, redundancy by design, and acceptance of failure as part of progress. The American industrial system can absorb lost satellites, delayed launches, and experimental iterations. The Soviet system, optimized for centralized control and minimal waste, cannot. Every failure must be explained. Every delay becomes political. Innovation slows under the weight of accountability. Industrially, the gap widens further. Precision timing lies at the heart of the system, and that means atomic clocks of extraordinary reliability. Producing them is not enough. They must be produced consistently, miniaturized, hardened for space, and synchronized across an entire constellation. This requires supply chains, specialized materials, and manufacturing tolerances that push beyond what Soviet factories are optimized to deliver at scale. Excellence exists, but not flexibility. NAVSTAR thrives on constant refinement, not rigid perfection. Scientifically, the challenge is just as severe. The system demands mastery of orbital mechanics, relativistic time correction, software integration, and real-time signal processing, all working together without human intervention. This is not a field that advances through secrecy alone. It requires open testing, rapid feedback, and interdisciplinary collaboration. The American approach encourages this chaos. The Soviet approach suppresses it. What NAVSTAR needs most is not just intelligence, but freedom to fail, adjust, and try again. And finally, there is the mental barrier, the hardest one to cross. Soviet doctrine is built around control from the ground up. Power flows from command centers through chains of authority to units in the field. NAVSTAR inverts that logic. It empowers every platform independently, giving precise knowledge directly to the edge of the battlefield. To adopt such a system would require not only new hardware, but a new way of thinking about war itself. By the time this becomes clear, the conclusion is unavoidable. The gap is not temporary. It is structural, and it is growing. In the end, what NAVSTAR represents is not a single American success, but the closing of an era. For centuries, war had been shaped by mass, by proximity, by the physical limits of human perception. Victory favored those who could move faster, hit harder, and endure longer. Even the most advanced weapons of the 20th century still obeyed these rules. They were extensions of muscle and metal. NAVSTAR breaks from that lineage entirely. It does not add force to the battlefield, it removes uncertainty from it. With the rise of satellite navigation, war begins to reorganize itself around information. Position becomes absolute, time becomes shared. Coordination no longer depends on constant communication or centralized control. Instead, it emerges naturally from a common, invisible reference that every unit can access simultaneously. The battlefield becomes transparent to one side and increasingly opaque to the other. Strength still matters, but it is guided, multiplied, and synchronized in ways brute force alone can never achieve. For the Soviet Union, this shift is devastating precisely because it cannot be countered with traditional responses. More tanks do not restore uncertainty. More missiles do not blind satellites. The foundations of military power have moved upward beyond the reach of conventional doctrine. The contest is no longer decided by who occupies territory, but by who defines reality itself, who knows where things are, when events occur, and how actions align across vast distances. NAVSTAR marks the moment war stops being fought solely on land, sea, and air, and begins to be fought in space and time. It is quiet, persistent, and absolute. There is no decisive battle to mark its arrival, no surrender ceremony to signal its victory. And yet everything that follows will be shaped by it. The age of visible dominance fades. In its place rises an era of invisible control, where wars are not ended by overwhelming force, but by systems so integrated, so precise, that resistance becomes irrelevant before it even begins.